Hello dear friends, welcome to this video in our YouTube channel. In this video friends, we are looking at one of the very important questions in the 2013 further mathematics with mechanics. So friends, we are looking at the paper, the way question of it was based on oblique impact. So friends, please, if you're new to this channel, don't forget to subscribe to the channel, because if you don't subscribe guys, you are not going to be having all latest updates about the great content we produce here. So friends, hurry hit that subscribe button and press the bell icon to get notified each time we upload new videos. So friends, it took me quite a lot of time and energy to prepare this great content for you today guys. Quite a lot of time. So please, the only way I want you to appreciate this is by giving the video a like. If you subscribe already guys, please give the video a like and share it with your friends. Make sure you comment on the video guys. Place your comments in the comment section down below guys. It goes a long way to motivate me. Good. So friends, the question reads that a smooth sphere S of mass m moving on a smooth horizontal table with speed u strikes obliquely an identical sphere T which is at rest. The direction of motion of S before and after impact makes an angle of alpha and 2 alpha respectively with the line of centers. The coefficient of restitution between the spheres is E. We should show all of these conditions. Alright. So friends, let's start by picturing a scenario of the problem. We know that this question was based on oblique impact, right? So in such a case, collision between spheres or between walls must always take place at some angle to the line of centers of the sphere if it's for two spheres. Great. So guys, we have the velocity in which the initial sphere was moving has a component that is responsible for the horizontal motion of that sphere. So that component of velocity guys is going to be u cos alpha, since they said the angle in which it was moving before and after impact was what, alpha, and 2 alpha means before was alpha, after was 2 alpha. But before then friends, let's picture the scenario. Let's just look at how everything looks like. Let's have the line of centers of the sphere. Let's have the first sphere. We can call that sphere S, and since the set sphere S was initially in motion, and it collided sphere T at some angle. But before then guys, let's have our sphere T. That's it. Great. So sphere S was moving with some speed, we can call that u, and it collided with sphere T obliquely at some angle alpha to the line of centers of the two spheres. Keep in mind friends that the line in green is the line of centers of the two spheres. It is still the same angle, okay? That is, this line is parallel to where? To this horizontal component that is responsible for the horizontal motion of this sphere, okay? So this angle is still the line of centers. It's still the angle in which the sphere makes with the line of centers. Great. Then friends, the vertical component of this speed has a value of u sine of alpha. Good. That's what we have friends. So after collision now, or before it collided with this sphere T, it is going to have this component which is still the same like u sine alpha. The upward component, we have it to be u sine alpha. Go ahead. Then friends, as for this our sphere T, since this equation said it was stationary, means its upward speed or its vertical speed is 0. Likewise guys, its horizontal speed as well is also 0. Good. Since it's at rest, means both its I and j components of speed are 0. Good. So friends, after they must have both collided, we are going to have our sphere S like this. This sphere S is still going to maintain back its vertical component of speed, which is still u sine alpha. Sphere T as well maintains it. It's going to maintain this its component of the vertical speed to be u sine alpha. Then it is now going to have some new horizontal speed. We can call that x. Good. Then now guys, as for sphere T, keep in mind that spheres are always going to maintain the component of their vertical component of their speed. In this case, they're moving in a horizontal manner. So after collision, they are going to maintain their vertical component of speed. So the vertical component of the speed of sphere T will still be 0, while the horizontal component of the speed, guys, is still going going to be y, some new speed, because here initially it was at rest, so both components of his speeds were 0. After this guy collided, the horizontal speed of this sphere T is no longer 0. It is going to have some value. You can call that y. Good. So now, guys, I think we have everything set up now. Let's go now to prove these are results. We are going to start with the conservation of linear momentum, guys, which simply tells us that momentum before collision has to be the same like the momentum after collision. And since momentum is mass times velocity, and we should keep in mind that sphere T initially has no momentum since it has no speed. So we are definitely going to have m into the component of the speed of sphere S that was responsible for the horizontal motion of sphere S is what? U cos alpha. So we have it plus the mass of the second. Since they said, friends, keep in mind that they said sphere S is of mass m, right? And it collided with sphere T, and they said it's identical, means they both have the same mass. Great. The question in this case did not tell us plainly that the mass of sphere T was m, but since the question told us that they are both identical, means they both have the same mass. Great. So this is the momentum before collision. Then now after collision, now we still have the mass of sphere S, which to be m. Its new speed, we can call that x. That for T, we can call it y. Good. So guys, if we cancel all the m's on both sides and simplify, we are going to have x plus y equals to u cos alpha. We can call this our equation 1. Great. Then now, guys, Newton's experimental law of restitution can give us, the formula is simply, guys, negative E equal to the difference in their speeds, in their final speeds, all over the difference in their initial velocity in this manner. So friends, simplifying so well, we are therefore going to have x minus y equal to negative EU cos alpha. We can call this equation 2. Great. So guys, to solve these are our two equations. Keep in mind that we need the speeds of sphere S and sphere T, because we are going to use the speeds now to answer all of these problems. Though the equation did not tell us plainly that we should look for the speeds, but in this case, guys, we need it. Alright, let's get the speed of sphere S first by simply adding up the two equations. Adding up the two equations, guys, is going to, this is negative y, right? This is y. So y and negative y, they'll cancel. We are going to have 2x equal to, we have u into, we've simply factor out 1 minus u cos alpha. So we have u into 1 minus e cosine of alpha. If we divide all two by 2, guys, we are going to have our x to be the same like u over 2 into 1 minus e cosine of alpha. Great. So guys, that's the speed of sphere S after collision. Alright. Now friends, if we take equation 1 minus equation 2, that is to get the speed of sphere T, we are therefore going to have 2y to be the same like u into 1 plus e cosine of alpha. If we divide all two by 2, we are going to have our y to be the same like u over 2 into 1 plus e cosine of alpha. That is the speed of sphere T. Good. Okay, now I think we have what it takes now to start this our proof. All right, let's start, guys. Now the question said that they make that after collision, right, the angle, the direction of motion of sphere S before and after impact made angles of what? Alpha and 2 alpha respectively. So after impact now, guys, the direction of motion of sphere S is going to be what? 2 alpha to the line of center. So we can indicate it here that here is going to be the new direction of motion of sphere S, and they said that this angle, the angle it made with the line of centers is going to what, guys? 2 alpha. Good. So with this, guys, we can construct some wide angle triangle and observe what is actually happening. We can, this our components, this components in yellow, we've represented it with this. Then for instance, now the vertical component of the speed, that is when we complete this right angle triangle, it is going to what, guys? Still u sine alpha, right? Because it is going to maintain this vertical component of speed to be u sine alpha. So we have here to be u sine alpha. Then horizontally, guys, this other, to complete this our right angle triangle horizontally, is going to what? X. So we are going to have it here like that. So this component up is u sine alpha. Then the horizontal component, guys, we can call it the value of x. And what is the value of x, guys? It is u over 2 into 1 minus e cosine of alpha. Friends, what you notice that if these our two answers are wrong, the proofs will not come out. Okay, we are going to be wrong. Definitely, we are going to lose the marks awarded allocated for this question. All right, so friends, let's indicate that this is going to be the angle 2 alpha. Great, that's the angle 2 alpha. All right, now friends, if we, since the Roman one is talking about tangent, right? Tangent, so let's try to involve tangent of 2 alpha in this case and tan alpha. We can get tan alpha by simply looking for the tangent of this angle, right? In fact, the angle is 2 alpha. So guys, tangent of 2 alpha in this case has to be the same like what? The opposite of our adjacent. Opposite is u sine alpha. Adjacent is what? U over 2 into 1 minus e cosine of alpha. Great, that's what we have, friends. Then if we simplify further by simply cancelling the u's on the top without the bottom and multiplying all through by 2, we are going to have our tan 2 alpha to be same like 2 tan alpha over 1 minus e. If we cross multiply by, if you multiply all through by 1 minus e, guys, we have the first proof. We have 1 minus e tangent of 2 alpha equal to tangent of 2 alpha equal to tan 2 alpha. Sorry, that's the first proof, guys. That's the first proof. Hope was pretty easy. So friends, please don't forget to like the video, friends. Subscribe to the channel if you want more great contents, guys, and please share the video out with your friends. That is a way of you motivating me to keep this channel going, friends. If you don't subscribe to the channel, you are not going to be having all latest updates, guys. And when you subscribe, please press the notification icon to get notified. Great. All right, friends, let's look at the next part of the question. Let's go to the next slide. Wow, great. All right, so friends, I believe these are the things we need. These are the things we need. All right, so let's look at the proof in which we ended with. Let's look at the Roman 2. That's what we ended with, right? Good. So now the Roman 2 now should show that e is the same like tan squared alpha. We notice that in this our proof, right, they don't have tan 2 alpha again, right? They have just tan alpha. So let's express tan 2 alpha according to our knowledge of trigonometry. Remember, tan 2 alpha is the same like what, guys? 2 tan alpha over 1 minus tan squared alpha, as we have it here. Then friends, we notice that there's a tan alpha here, right? And there's also tan alpha here, so they can cancel. And if we simplify further, guys, we are definitely going to have if we cancel tan alpha this way and cancel this way and we cross multiply, we are therefore going to have 1 minus e to be something like what, guys? 1 minus tan squared alpha. We have a 1 here, you can cancel with the 1 here, and we also multiply by negative. We are going to have e to be tan squared of alpha. Great. That is what the second proof is saying as required, guys. That's it. All right, then the next question I want us to show that tangent of alpha is between 0 and 1, including 1. Good. All right, so friends, what we are to do is that we are supposed to use our knowledge of the intervals to which e is found. Good. So friends, we should keep in mind that that normally during any collision, guys, e is always from 0 to 1. It's always between 0 to 1 inclusively. Okay, that is for normal collisions. If we don't know if the bodies if the colliding bodies came to rest instantly or they came to rest later on. So friends, and we should also know that when the two colliding bodies collide and come to rest immediately after impact, guys, we can tell them that our e in this case is 0. But in this scenario, we're told that this sphere T was at rest, right? And as soon as both of them collided, as soon as sphere S collided with our sphere T, they both were in motion, right? Because we just found a value for their final speeds after the impact they had. So none of the values there were zero. So in this case, guys, our E in this case can never be zero. So this inequality sign here is restricted. Okay, this sign now this inequality sign now is now made to be strict. So guys, in such a case, we can therefore tell him that in this case now our E is rather between where from 0 to 1, including 1 and excluding 0. But friends, what is our E in this case? What's our E according to our initial proof? It is tan squared alpha, right? So that implies we are going to have 0 to be less than tan squared alpha less than or equal to 1. If we take the square root on both sides, guys, we are going to have 0 to be less than tan alpha less than or equal to 1. Good. That is the proof, guys. That is what we have been asked to show in this Roman 3. All right. Then, guys, the Roman 4 is saying that we should show that alpha is less than or equal to pi over 4. So, friends, we can simply use the portion of this, our inequality, our expression, which is talking about tan alpha less than or equal to 1. So, we are going to have tan alpha less than or equal to 1. That therefore implies, guys, alpha now is less than or equal to the tan inverse of 1, which that gives us alpha to be less than or equal to pi over 4. Great. That's it, guys. That's it. It was easy, right? Great. All right. The next paragraph, the next part is saying that in the case where alpha is pi over 6, we should find the loss in kinetic energy due to the impact. Okay. So, friends, let's take note that initially, only sphere S had kinetic energy, right? Sphere T has none since its speed was 0. So now if we substitute our alpha to be pi over 6, where we have the initial velocity of sphere S, keep in mind that cos pi over 6 is the same like what, guys? Cos 30, right? And cos 30 is what? With 3 by 2. Good. So this is now going to be our US. That is the initial speed of sphere S is going to be S equals to 3 on 2 U. Then, guys, the final speed of sphere S, let's keep in mind that this is the final speed of sphere S that we found initially, and that of sphere T, this is it we have initially. So when our theta now takes a value of pi over 6, so we are therefore just going to have x to be the same like 3 over 6 U. Keep in mind that our E, when we replace alpha here to be the same like pi over 6, right? Where we also replace our alpha here and simplify, we are going to substitute and we are going to have our x with that. Doing the same, we are going to have y to be 3 over 3u, and as you all know, our E is 1/3 where we replace the value of alpha here as pi over 6. Good. All right, so let's keep in mind that the KE loss, the kinetic energy loss, guys, is simply given as the kinetic energy initial minus the kinetic energy final. Great. So, guys, if we put everything, guys, keep in mind that kinetic energy is simply 1/2 mass times velocity squared. So the initial kinetic energy, like I said initially, guys, that only sphere S had some initial KE. Sphere T has none since its initial speed it was 0. So we are therefore just going to have 1/2 into initial speed of sphere S, as you all know, is 3 by 2 U, everything squared, minus now, okay, now, guys, after the final kinetic energy is simply 1/2 m. The V now has to be the final speed of sphere S, which is 3 U over 6 squared, plus that of sphere T. Good. So if we simplify further, guys, we are therefore going to have 3 over 8 mu squared minus 1/2 mu squared into, when we factor out 1/2 mu squared from in the right hand side, we are going to have 1 over 12 plus 1 over 3. Simplifying further, guys, gives us our answer to be 1 over 6 mu squared. Great. That's it, guys. That's what we are required to find. So, friends, I hope you found the video useful, guys. I hope you enjoyed as well. Thank you so much for watching the video, and don't forget to subscribe to the channel so that you will not be missing on any of our latest updates that we have, friends. Thank you, and have a blessed day.